Hello, in this video we are going to have a look at one of the properties of a Cobb-Douglas function, which is that a Cobb-Douglas function satisfies the Euler's theorem. It's spelled as E-U-L-E-R-S and pronounced as Euler's theorem. Now, the Euler's theorem is a general theorem that is applicable to all homogeneous functions. It states that for a function such as z, which is a function of x comma y and homogeneous of degree r, the following property would hold. Now, we know that a Cobb-Douglas function is represented as a L to the power alpha k to the power beta, and its degree of homogeneity is the sum of the powers or the exponents of labor and capital, and therefore it is alpha plus beta. So, restating the Euler's theorem in terms of the Cobb-Douglas function variables, we can express the Cobb-Douglas functions, production functions, Euler's theorem as partial differentiation of Q with respect to L multiplied by the units of labor employed plus partial differentiation of Q with respect to the second variable, which is capital, times the number of units of capital employed. This will be equal to alpha plus beta times the total output Q which is being produced. Now, we know that dou Q by dou L is nothing but marginal product of labor times labor, number of units of labor employed, plus marginal product of capital times the total units of capital being employed is equal to alpha plus beta times Q. For a linearly homogeneous Cobb-Douglas function, remember, linear homogeneous function means the degree of homogeneity is equal to 1. So in the case of a linearly homogeneous Cobb-Douglas production function, I can write this as MPL times L plus MPK times K is equal to Q, since alpha plus beta will be equal to 1. Now, we can try and prove this. It's pretty simple if we are using our initial properties and their proofs to aid us. So, we know that the marginal product of labor can be expressed as alpha, which is the exponent of labor, times Q by L, and similarly MPK can be expressed as beta times Q by K. Remember, we have proved this in our earlier properties. So we are just continuing from where we left off at the second property that I discussed with you. So substituting this into the equation, we can write it as alpha times Q by L into L plus beta times Q by K into K. This being the left hand side of the equation, LHS, right? So this can be expressed as, since L and L cancel, K and K cancel, this can be expressed as alpha times Q plus beta times Q, which is nothing but alpha plus beta times Q, which is equal to the RHS, or the right hand side of this equation. Hence, proved.